Hello again and welcome to lab number 3 of this course. In this lab we're going to talk about how to inject a default route inside our OSPF area. So if we have one router which is connected to the internet, for example, and he is also connected to the OSPF, how can he let all the other routers see him as the default route so all other routers in the OSPF can go to the internet? Okay, so we are going to pass through all those points you can see here, the 8 points. And inside the lab, I'm going to explain to you many topics also. So we go through type number 5 of LSA. We will speak about the ASBR and we will speak about the redistribution. Also, we'll see a little bit again about the cost. Okay, so this is a very nice lab to follow. Let's go directly now and see what is our lab scenario. So here, as you can see, this is our lab scenario. We are still using the same scenario of the previous lab, but what I've done here, I just took out, there were here router 4 was connected to router 2, and then here there were the RIP in the previous lab. So I took this out, and what I did, I just connected router 2 to the internet. Okay, so we still have the same configuration. We still have here the summarization of those routes done by router 5, and all routers are already now on OSPF. So we don't need to configure OSPF anymore. Okay, the task now is to have router 2 connected to the internet, because now he has a cable connected from his Ethernet 3 to the internet. So we need to have first the router 2 on the internet. And then afterward, we will see how can router 2 let all other routers in all the OSPF areas over here can use him to be like a default route or the default gateway to let all those routers to go to the internet. Okay, so this is really what we need to do now in this lab. Before we start with the labs, I just want to show you how I could add the internet here on the GNS3. Okay, so I open now GNS3. So this is exactly how GNS3 looks for me now. Okay, you can see here this cloud is my computer to be able to connect to the all routers over here. Okay, so this is my computer. I just added inside of it my loopback or my GNS3 loopback interface. I named it myself GNS3. It's a Microsoft loopback to be able to connect to all this network. Over here, what I've done, I just created a new cloud. So I just went from here and I dragged and dropped the cloud, this one. Okay, and from this cloud, you can go to configure, and then you will add your interface card where the internet is connected to. Your real interface card on your computer. Okay, in my case, you can see I have Ethernet 2 and GNS3. This is for the loopback. I don't need it. I just added Ethernet 2, the internet card that on my computer that has the internet. Okay, and then what you only need to do is put the switch and put the connection. Okay, so that's how we can have the internet on our GNS3, and we will see now how we can get all those routers to be connected to the internet, including router 2. Point number 2. Configure router 2 to receive internet connection with a default route from the ISP. Okay, if we want to look here in this lab scenario, we have router 2 has the Ethernet 3 interface connected to the internet now. And as we know, ISPs, they always have the DHCP server over here enabled to be able to provide on each of the routers of each of the customer the IP address, the subnet mask, the default gateway or the default route, and the DNS servers. Okay, so for this router to receive all this information from the DHCP server of the ISP, we need to enable the DHCP client on this interface. Then when you enable the DHCP client, in this case, they can communicate with the DHCP client of router 2 with the DHCP server of the ISP, and then the DHCP server will lease the IP address, the subnet mask, the default route, and the DNS to the Ethernet 3 of router 2, and in this way, the router 2 will go to the internet. So let's try and see if it works. Here I am on router 2 now. What we need to do, we have to go to IP and the DHCP client, and we said that we need to enable the DHCP client on Ethernet 3. Then Ethernet 3, I will keep it checked the use peer DNS to receive the DNS, and use peer NTP is not important. We can leave it. That's okay. And here also we need to leave the add default route, so we can get a default route also to be able to reach the internet from the ISP. And then I will say okay. Directly we see that now he has received an IP address. Point number 2 is done. Now we need to check if router 2 is online by using the ping command. I'll go again to router 2, to new terminals, and I will issue ping 8.8.8.8. That's a DNS server, a public DNS server on the internet that's working. Also, if you want, you can ping, for example, google.com, ping google.com, and here we go. We have a ping. So you can see how nice now I have a DNS-free router. MikroTik router is able now to be connected to the internet. Okay, so till now we're doing well. So point number 3 is also done. Point number 4, make the configuration needed so all routers receive a default route from router 2, and the cost of the route to the internet has to change automatically. Okay, so what are asking us here? We said that router 2 now, it has the internet connectivity enabled on it. Okay, so there is internet here. Router 2 has one interface connected to the internet and one interface on area 0, which is E1, and also E2 is in area 0. That means in this case, this router is an ASBR, okay, a autonomous system border router. Remember, ASBR is a router which has one interface or more connected to the outside than the OSPF, like for example here the internet, and it has connectivity with the OSPF. Now they're asking us here to let router 2 inject the default route to say, hello, I'm here, the router where you can reach from me the internet. So he has to inject to the OSPF area 0 a default route, okay, and he has to say that if you want to go to the internet, you have to go through me, okay, and I can take you to the internet. And that's something he needs to do it on area 0, but also it will go to all other areas. Now, they ask also another point, that we need to make the redistribution of the default route, the redistribution, we need to let it be changing with the cost. For example, remember when we were talking about OSPF, we said that if we don't touch the cost, always the cost is 10. Okay, so that's 10, 10, 10, and so forth. When we inject, let's say, the default route, which takes the router 2 to the internet. So when we inject that inside the OSPF, okay, then router 1, he will say, okay, for me to reach router 2, I need to have the cost, which is 10, plus the cost which takes me to the internet. We will see it in a moment how much it is. So in total, say if this is 10 and this is 1, then in total he needs 11 as a cost. That's on router 1, let's put it here. And then router 5, he will say, okay, for me to reach the internet, I need to have, the cost will be of my route will be 10 plus 10, that's 20, plus 1, that's 21. Okay, so you can see each router has a calculation for the cost by himself. Okay, and that's what they're asking us, that to insert the default route inside the OSPF, and each router has to make the calculation to see what is the cost for him to reach to the internet. Okay, so this is really the question that they're asking us to do. Here I am on router 2. First, let me go to routing and OSPF on router 2, because that's the router which has the internet, correct? And then I have to go inside instances, and then from here I'll double click here, and what I have to do here, we have redistribute, default route, connected route, static routes, RIP, BGP, and so forth. So I need to do here redistribute a default route, and I put it always as type 1, or let's put it if installed. So if we have the default route installed, in our case we do have, and just to show you, we can go here to IP routes, and we can see that when we have enabled the DHCP client, we said that we need to keep it checked to receive a default route, and then he received the default route here. It's dynamic, active, static, saying that to go to anywhere, that's a default route. You have to go to 10.0.0.1, okay, which is reachable on Ethernet 3. That's Ethernet 3 of router 2. Okay, so what we need to do, we need to redistribute this default route. Okay, we need to redistribute it inside OSPF so all other routers can reach them. Again, we go here to OSPF, to instances, and then here, if installed, as type 1. And why type 1? I will explain it in a moment, but let's first say, okay, so if installed, the default route is installed. Okay, so we have a default route already installed, and if it's installed, you have to redistribute it inside the OSPF as type 1. And now if I go to, for example, route here on router 2, we can see that he has added here and it has a cost of 1. That means if I go back to the picture here router 2 said that the OSPF here, the cost is 1, and that's what OSPF have seen it. Okay, so it has a cost of 1 here of our OSPF. That means that router 1 to reach now the internet, he needs to have, here is the cost 10, then 10 plus 1, it is 11. And that's why we said type number 1. You have 2 type on OSPF when you want to redistribute. You have type 1 and type 2. The difference between the two, type 1, it will calculate the cost. Every router will calculate the cost, how much it needs to reach the internet. Okay, as I explained previously. Type 2, they will not calculate the cost. They will only take the cost of router 2, which is here 1. Okay, so that means router 5 in type 1, he will say, well, I need 10 plus 10 plus 1, I need 21 as a cost to reach the internet. If we use type 1, okay. But if we use type 2, then router 5 will say, I need only 1 as a cost to reach the internet. So we go back here to router 2, and then what we can now check, we can see if the route has been received to other routers. But before we do that, let me just show you here the LSA also. That's something good to show. You can see here, we knew about the router, the network, the summary, that's type 1, type 2, type 3 LSA. Now we can see now there is an AS external, and that's type 5. That's a LSA type which normally comes when you have a ASBR, when you insert or inject an external route, and then in this case you will see the LSA type 5, and you can see here it's originated from 2.2.2.2, which is router 2. Okay, now I want to go to router 1 and see if he has received the default route. Let's first go to routing, OSPF, and then here the routes. Indeed, we can see that he has received it. This is the default route he received, and you can see here it is type 1, okay, and it has a cost of 11. And again, why it has a cost of 11? Because router 1 has calculated 10. That's over here. That's 10 the cost plus 1. That's 11. So he's saying that if I want to reach to the internet, I need the cost of 11. Okay. If I want to go to another router, say, let's see here, we have router 5 possibly, or router 6. Let's see, yeah, router 6. Router 6, if I go to routing, OSPF, routes. He has also received here the default route, and you can see here, he has 31 to reach to the network. Why? Because if we look here to the graph, that's router 6. So he has 10 here to router 5. And from router 5, he needs 10, and 10, that's 30, and 1, that's 31. But also, we will see that router 6 can also go from this way. Like 10, 10, 10, plus 1. So we can go like this, or like this, because they have equal cost. And remember, OSPF can do load balancing using equal costs, correct? So we go again to router 6 here, and if we want, you can go to IP route now, and we see inside the IP route, inside the routing table, also he received, it's shown here that he has received the default route, and it's saying that you need to go, router 6, he needs to go to 56.5, and 56.5 is this IP here. So router 6 is saying to reach to the destination or to the internet, to the default route, you have to go this way, which is 192.168.56.5, which is the IP address of Ethernet 3 of router 5. Okay, so make the configuration needed so all routers receive the default route from router 2. We've done that, and the cost to be changed also, we've done that by setting the type 1. Okay, now can all routers go to the internet now? If not, then fix the problem. Let's see. I will go to router 1 now. This is router 1. We see that he is receiving, if we say IP routes here, he is receiving the default route, okay, from router 2. But can they go to the internet? Let's see. I will try to now ping again 8.8.8.8. And as you can see, it's giving me a request timed out. There is nothing wrong with the default route actually that we have inserted. The problem is if I want to show you here what is the problem. The problem now that those IPs over here are not recognized by the ISP, because you need to issue here a NAT, a network address translation. Okay, if you don't know about the NAT, I have another course that you can register on, and I explain in details about the NAT, but just like a brief, network address translation is to translate those internal IP addresses here, the private IP addresses, to the IP address of the internet of the ISP in order for them to go to the internet. So now what's happening, that router 1 is able to reach router 2, but he cannot go to the internet because it's missing the NAT here. So what we need to do, we need to configure NAT on router 2, network address translation. So let's do that very fast. I go to router 2, that is router 2, and then from here I say IP firewall and to NAT here, and then plus. So here I'm saying for any IP address source coming from the inside network, okay, you can only say here the action is masquerade. So you can also specify here if you want the source address, or you can specify the interface, the interface or out interface. But if you don't do that, for now it's fine. Any IP address coming to the router, you can do the NAT, so it can do the masquerade, and then okay. All right, so now I'll go again to router 1 and I will try to ping again, and here we go. You can see I have now internet on router 1. So can you imagine now that all those routers are on GNS3, they are now connected to the internet. And if you want, we can ping also google.com. Oh, in this case we need to put the DNS server, so we can do that. We can go to IP and then DNS, and I can put the public DNS, for example 8.8.8.8. okay, and then now if I ping google.com, then it is working. So I have now my router 1 connected to the internet, and of course all other routers will be connected. For example, let's pick one, router 7. I will go to the command line here, ping 8.8.8.8, and here we go. Okay, so router 7 is on area 2, and it's another area, but he can also go to the internet, which is very cool. All right, so that was the problem that we had to fix. We had to configure NAT on router 2. Point number 6, make the configuration needed so all routers receive a default route from router 2, and the cost of the route to the internet has to be fixed. Again, remember type 1 and type 2. Type 1 will change the cost, type 2 doesn't change. So let me go to router 2. Before I go to router 2, I just want to go to router, say we go to router 7. Huh? Let's go to router 7, and from router 7 I will go to routing OSPF, and here inside the route, and we can see that router 7 at this moment he needs a cost of 21 to be able to go to the internet. Okay, he needs 21, and that's because if we go here to router 7, he has here cost is 10, and here cost is 10, and here is 1, so he go this way. Okay, then he needs 21. Now I want to inject it as type 2, and then in this case we will see if it will stay 21 or it will be changed on router 7. Okay, I go to router 2 now. That is router 2. I close this one, and then I go to routing OSPF to instances, and from here, and if installed, put it as type 2. And then okay. All right. Now I will go to router 7 now. Let's see. This is router 7. And here we go. You can see directly that now the cost is 1. And you can see here that it's saying it is type 2. Okay. Same if we do on, let's pick another router. For example, router 5. Router 5 had to have 21. Previously it needed 21. Now it should show us also 1. Okay, and you can see here 2. And here what I wanted to say here, router 5, he can go from Ethernet 2 or Ethernet 1. Why? Because router 5, he has equal cost. He can move from here to here, or from here to here. Okay, so he has 2 possible routes to reach to the internet. Okay, alright, so point number 6 is also done. Can all routers go to the internet? Let's check now. On router 7 we are now. I'll go to ping 8.8.8.8 and here we go. It is on the internet, and router 7 is on area 2. So yeah, they can go to the internet. That's not a problem. That's fine. And now they ask us, what is the difference between always and if installed in the redistribution? So if we go again to router 2, that's router 2. Yeah, when we were here redistributing the default route, we've seen that there is if installed and if there is always. If installed, that means that if the default route is on this router, in our case it is, if we look here, IP route, we received it from the ISP. So if this is installed, then you can redistribute it, and then you can choose if you want it type 1 or type 2. Okay. The other one is here, always as type 1 and as type 2. That means that if you always want all the routers in OSPF to always see router 2 as their default route, even if there is a default route, if there is no default route coming on router 2, but router 2 should be always the default router or the gateway for all other routers in the OSPF. In this case, if you have the default route coming from the ISP or you don't, the router 2 will say that I am the gateway for all the routers in the OSPF and you can use me to go to the outside world. Okay, let's do that. For example, what I want to do now, I will, so this is the explanation, but let's do it like a small step. I will go to router 2 and to DHCP client, and here I will disable it. So I don't want that router 2 now go to the internet anymore and doesn't provide internet to other routers. Okay, so when we disable the DHCP client, then in this case, if we go to IP routes, we don't receive anymore the default route from the ISP because we don't have any more communication between the DHCP client on the Ethernet 3 of router 2 and the ISP. Okay, so there is no default route coming from the ISP, but I still want that my router 2 to be saying to all the OSPF routers that he is the gateway. Okay, so in this case, I can go to routing, OSPF, and now as it is installed now, it says if installed, then redistribute it as type 2. So if the default route is installed, then redistribute it as type 2. At this moment, it's not installed on router 2, the default route. That means if I go to, for example, router 1, we will not see it. So we go IP route. You see there is no more any default route here. It's gone because it's not installed on router 2. If we want also, you can look in OSPF. You can see here there is no more default route on route because again we've said here on router 2 that if the default route is installed, then redistribute it. But I want that the router 2 to be always the gateway. So even if it's installed or if it's not installed, just I want it to be the gateway. So here I can choose redistribute default route always as type 1, and then I say okay. So here I'm saying always, if there is a default route, if there is no default route, I want to redistribute always, and it has to be type 1. Okay, and now we can see on the router 2, so it has now shown here. And then if I go to router 1, OSPF, and here we go, you can see it now. Okay, but of course router 1 cannot go to the internet now, so yeah, we have it router 2 as default route, but that's always good to do it because sometimes, for example, if you want to have your network always converged, say that your router 2 is disconnected from the ISP, and then in this case, if you put it if installed, then this will be not shown on the router anymore, the default route. Okay, but it could be that the internet will come back later. Let me just explain this to you here. So when you say if installed, then if this route is installed coming from the internet to here, if it's installed here, then it is redistributing inside the OSPF. That's fine. But what if your Ethernet 3 is not working well, or your cable here? So it's like the connection is up and down. The interface is going on and off on this interface. And then in this case, you will have a lot of CPU usage here for all the routers over here because they are calculating and recalculating every time the link is coming on or off. So if you are sure that you will always have connection from the internet on Ethernet 3 here, and router 2 will be the one, then you just put it always. In this case, you have more conversion, even though that the connection cut here, that's not a problem, because all the router will still look at router 2 as the gateway. Okay, so that's one of the reasons why to use it. And also you can use it as type 1 and as type 2. So it's the same. Type 1, it will calculate the cost, and type 2 will not calculate the cost. Let's see now if we still have to do something. So point number 8 is, we said what is the difference. Now one more thing to mention here, and that's something maybe we missed it. If we go to OSPF, we will see that the ASBR, the Autonomous System Border Router, is router 2. And that's because, if we open here the picture, because router 2 is connected to the internet, so the outside, and to the OSPF. Okay, so if we go to router 1 and we go to routing, OSPF, ASBR, and then we can see also router 1, have seen it, the router 2 as the ASBR. Okay, so router 2 at this moment is the ASBR. As we can see here in the picture, this is now the ASBR, router 2. These are internal, there is internal router, there is an ABR, and there is an ABR, and this is internal router for area 2, and this is internal router for area 1. Okay, sometimes also you can call router 1 a backbone router. Alright, so this is what I wanted to show you in this lab. This is how you can connect your routers to the internet, and this is more than one topic. So actually we've talked about the redistribution, the ASBR, the type 5, we just talked about it, and type 5 LSA, we just talked about it, and also the type 1 and type 2 when you redistribute. So there are many topics inside this lab. I hope you enjoyed it, and I see you in the upcoming lecture.